Hey everyone, welcome to dot point A10. So today we're looking at identifying the factors that limit fertility of farm animals, including genetics, environment, pests and diseases, management, and nutrition. So because it's an including dot point, we need to be able to know all of these things. So we need to know how genetics can limit fertility, environment can limit fertility, pests and diseases can limit fertility, management or what the farmer does, and nutrition and how they can limit fertility. It's only an identified dot point, so we don't need to know extensive information, but we need to know enough to identify these factors and a little bit of an outline of them. So first of all, we need to know what fertility is so we can work out how these things actually limit fertility. So this first little bit here is basically out of the textbook, and it says fertile animals are those that can reproduce themselves efficiently. If an animal is taking many years to become pregnant and just cannot get pregnant, but then one day does, it might be technically fertile, but it's not very efficient at that. So it's not going to be preferred by the farmer, and it's not going to be economical for that situation to occur. So a fertile animal is considered one that is able to reproduce itself efficiently. They're able to ovulate or produce an ovum or an egg successfully, become fertilized, and produce young. So all this is happening without any major complications. And most of the factors that influence fertility are under the control of the farmer, and therefore knowledge of these factors help reduce infertility. So if we have a look here, as we saw in the dot point, there's factors that affect fertility, genetics, nutrition, climate, disease, pests, and management. Now, management is over and above all of these things because management can control each of these factors listed before it. So let's have a look at each of these factors in order. So firstly, let's look at genetics and how genetics limits the fertility of different animals. So firstly, we have a difference between species themselves. So for example, with pigs compared to cows, pigs or sow, a female pig, a sow, can produce 2 litters per year of piglets, with 11 piglets, versus a cow just producing one calf per year. And so clearly there's a difference there in fertility and the ability of that species to reproduce and replicate itself. There's also a difference between breeds. As I wrote here, Border Leicester, the sheep has a much higher chance of twins than a Merino ewe. So that is another difference in genetics and how genetics limits fertility. So Merinos are a little bit less fertile than Border Leicesters. Also, some animals are infertile because they inherit some kind of genetic abnormality, and that could be in the reproductive tract, it could be in the endocrine system, so they might not be able to produce the required hormones to actually be able to reproduce and for their reproductive system to function properly. So if we look at nutrition now, the second factor that might limit fertility. Firstly here, the rate of development of reproductive organs and puberty are determined by body weight. So it's not so much age that determines puberty, it's more body weight. And we see that in humans these days, that puberty and reproductive organs development is happening sooner. I guess people are a bit heavier and are getting heavier sooner at a younger age than they used to be decades ago. So really the onset of puberty and development of reproductive organs are determined more by weight rather than age. So we've talked a bit about flushing and providing a ewe with an increased level of nutrition prior to mating, but if an animal has poor nutrition, it will have an irregular estrus cycle, it will have decreased ovulation, and that will lead to lower fertility, and offspring will be small and weak. And so we can prevent this by flushing, which is where we increase feeding to the animal, to the ewe, prior to it being joined or mated with the male, and that increases the chance that it will actually successfully conceive and increases its fertility. Here we have another kind of the opposite end of the spectrum. If you have an increase in feeding, so you give a late stage pregnant ewe or cow a large amount of food towards the end of the pregnancy, it could cause a difficult birth because the calf has grown significantly large, and you get a problem there called dystocia, where the calf or the lamb is quite large and has birthing difficulties, and that can obviously lead to death potentially. On the other hand, with males, if you overfeed males, it's potential it can decrease their libido and they have a lower sex drive. If we move on to climate, there's various factors to climate, such as temperature, such as day length. But generally speaking, with temperature, if temperature increases, then there's an increased chance of the embryo not being born, or the fetus not being born, and embryonic mortality in the womb, and a decrease in birth weight in pigs and lambs if the temperature is consistently high. And that obviously leads to a greater chance of death. If we have an increased temperature, this decreases male sperm production. So hot weather stops or slows down or has a bad impact on male sperm production. On the other hand, a lower temperature and wet and windy climate leads to a higher loss of lambs, as they just can't survive in that weather. Moving on to day length, some animals are dependent, their breeding season is dependent on the weather or the day length and the season, the time of year. So pigs and cows are polyestrous, meaning many estrus cycles. Their estrus cycle occurs over and over again at any time and is not linked to any season. However, goats and sheep are seasonally polyestrous, which means they, depending on the ratio of day to night and the day length, that affects whether they breed and what time they breed during the year. Okay, moving on to disease and pests. We have examples here. Vibriosis is a bacteria that leads to infertility and abortion, and leptospirosis causes a fever, which also can lead to abortion. If the animal is sick, unwell, it clearly probably is trying to fight that infection, even if it's elsewhere in its body and not in its reproductive organs. It will reduce the reproductive capacity, because the animal just has less energy and just less ability to actually reproduce at that time. And then lastly here, of course, pests and diseases could actually directly affect the reproductive organs, in which case the sperm or the ova or the passage or implantation can cause abortion potentially. So that's how disease and pests can limit fertility. Lastly, there's a number of steps here in terms of management, in the way that farm management or management just simply means things the farmers can do. So you could potentially write here, things the farmers can do is what management or management strategies are. So firstly, the farmer wants to be able to detect heat accurately. So when the cow is on heat and it's willing to mate, when you're, say, artificially inseminating a cow, you want to know that it is ovulating and has an egg that needs to be implanted. Otherwise, if it doesn't, the fertility rate is going to drop off significantly. You might selectively cull to remove infertile animals. If you have an animal that might be able to reproduce but is not very good at doing it, maybe it only has a calf every couple of years instead of every year, you want to get rid of that animal, because it's going to pass on its genes to its offspring, and they might also have that infertility problem. So a good farmer will remove those animals, maybe selling them or culling them. Number 3, you want to determine the optimum mating time, and when the activity is at its highest. You also need to think about the climate and the market, the climate when the offspring will be born, and the market that will be around the time that they're born or beyond that, and that will have an impact. That will be things that have to do with fertility. Of course, you want to prevent and control disease, as we've already talked about, because that can limit fertility. As we've talked about, nutrition can limit fertility, so a farmer clearly can provide enough nutrition. And lastly, with management, you want to, if you're naturally mating animals and not doing it artificially through artificial insemination, etc., then you want to make sure that there is sufficient male animals to the number of females. If you just throw in, say, 1 ram into 1,000 ewes, clearly most of them aren't going to be pregnant, and the fertility rate will be very low. Okay, so moving on, factors that affect male fertility include the following. So this is kind of focusing more on male. The previous ones really had a large focus on the female. So factors that affect male fertility: soundness of the animal, the actual structure of the animal affects whether it can mate successfully or not. Serving capability is talking about the the number of sperm and its ability to mate with females. As we've seen, nutrition and climate also affect males. The scrotal size, so the larger the scrotal size, the larger testes the male has, the more testosterone, the higher libido, the more sperm, etc., which means it has a higher serving capability, and obviously libido will affect the willingness of that male animal to mate will affect fertility. Secondly, how can we reduce these factors? How can the farmer change these? You don't want to use an animal that's too young or too old, as that's going to reduce their libido and their serving capability. Culling animals that are not fertile enough, having sufficient ratios, as we mentioned, and controlling disease. This second last point here, what influences the fertility of a ewe? So things such as age, breed, climate, and nutrition all affect the fertility of a ewe, and describe how some of these influences can affect production and fertility. We know that if we have, for example, if we flush an animal by giving it a ewe, for example, give it high amount of nutrition prior to joining or mating, it will increase the chance of twins and ovulation. And also we know increased nutrition late in pregnancy can lead to an increase in dystocia. All right, so moving on to HSC questions. This first one from 2015 described the effect of 2 factors on the fertility of farm animals. So you could choose any 2 of the 5 that we just looked at. Now what I've done here is I've just gone to the Board of Studies or Education Standards Authority website, and I've pulled off the sample answer from the HSC from 2015. So this is what HSC markers sit down and write as they're marking the questions, and they'll write down what is the minimum required to get the full marks. Now, it often might seem short, but it's the absolute bare minimum required to get full marks. Now, of course, there's 1,000 ways that people could answer a question, and it's certainly not the only way to answer a question, but it just gives you an example of like a really simple, really brief answer that would meet the criteria and would get you full marks. So describing the effect of 2 factors on the fertility of farm animals. The first one is high temperatures or climate may reduce the libido and sperm count in males. That's good so far, which reduces their reproductive capacity. Okay, so this extra bit here at the end really kind of makes sure that the mark is received there. Poor nutrition during pregnancy, so nutrition is the second factor, may result in high rates of stillbirths and or the birth of small weak offspring and have a reduced chance of survival. Okay, so that's, like I said, that's basically the minimum required for a 4 there. What is meant by the term flushing when used with reference to animal production? As we said, it's an increase in nutrition prior to mating. All those other ones are wrong and clearly wrong. Which of the following is the most likely consequence for farm animals under conditions of sustained high temperatures? So that's not going to relate to puberty, it's not going to relate to increased birth weights, and it's not going to relate to increased ovulation. It will, however, reduce the fertility in male animals and lower the sperm count if there is sustained high temperatures. So the answer is B. Moving on, 2013, farmers often increase the quantity and quality of food available to females prior to placing them with the male animals for mating. What is the principal reason of doing this? So again, this is going back to flushing, which came up in 2015 paper. Increasing the length of estrus cycle, no. Milk production, no. Remember, this is prior to mating. Chance of survival of offspring, no. It's too early for that. It's before mating. The answer is to increase the rate of ovulation in the breeding stock. The answer is D. Okay, so which combination of factors, also from 2013 paper, is most likely to affect the fertility of farm animals? Day length does have an impact. Topography, the shape of the land, doesn't. Nutrition, diseases does. Nutrition does. Day length does. Light intensity doesn't. And again, light intensity doesn't, and neither does topography. We know that nutrition, genetics, and disease all do, and that is by far the best answer, A there. So for this one here, 2013, outline how nutrition affects the fertility of farm animals. This is a really easy question for 2 marks there. You can talk about anything you want. Again, I've gone to the Board of Studies or Education Standards Authority past paper, and pulled out the sample answer from the marking guidelines. And this is the sample answer to get the minimum amount of writing to get the 2 marks there. And of course, there's more than one way you can answer this question. So You could answer it in many ways, but here's a sample answer. In female animals, poor nutrition may lead to the cessation or stopping of estrus, reduced rates of ovulation, and reduced birth weights of offspring. Poor nutrition in male animals usually results in a lower sperm count and reduced libido. So that's a good answer for 2 marks there.